देव सर प्लीज
अच्छा
अनम्यूट।
ओहो सर कांति सर सर नमस्कार हाँ हाँ ଆପଣ ସାଙ୍ଗରେ ସାର୍ ଲାଷ୍ଟ ଦେଖା ହେଇଥିଲା ସେଠି ନାଇଁ BSCCT ରେ
ଆଜ୍ଞା sir। ଦେବ सर ଆପଣଙ୍କ ଅନମ୍ୟୁଟ sir।
ତ ମୁଁ ଭିडिଓ ମୋର ଏଟା ଭିडिଓ ମୋଡଟା ବନ୍ଦ କରି ଦଉଛି ହେଲା
sir
ଅନ୍
sir देव sir
देव सर ना देव सर से नमस्कार कर ली हाँ सर नमस्कार सर देव सर कैन यू ऑडिबल सर
sir देव sir प्लीज अनम्यूट sir।
हेलो
हाँ सर नमस्कार सर SS पंडा सर हेलो
संतोष
sir ଏବେ ସୁବିଲା sir।
ମୋ ସାଉଣ୍ଡ ଶୁଭୁଛି ମୋ ସାଉଣ୍ଡ
ହଁ sir ଶୁଭୁଛି sir।
अच्छा साउंड को कहीं कनेक्ट होनी
sir देव sir ଆପଣଙ୍କୁ ସୁବିଲା sir। देव sir
हाँ ଏବେ ଶୁଭିଲା
sir ହଁ sir ସାର୍ ଆପଣଙ୍କ ସହିତ କଥା ହଉଛନ୍ତି sir ପଣ୍ଡା sir।
ନାଇଁ ମତେ କ୍ଲିୟର ଆସୁନି ଏବେ ଆସିଲେ
sir ଏବେ ଆସିଲା ତ
सर नमस्कार केमती अछंती सर ठीक अछंती
ହଁ ସାର୍ ଭଲ ଅଛି
ओहो सेठिकार केमती अछि एनवायरनमेंट
ସାର୍ ଯାହା ପୂର୍ବରୁ ଏବେ ସେୟା କିଛି
से
ଚେଞ୍ଜେସ୍ ନାହିଁ ସାର୍ ଆପଣ କେମିତି
मो तो
ଅଛନ୍ତି
ठीक ठीक अच्छे मु तो जीवार अच्छे बे 20 तारीख
ବୁର୍ଲା ଆସିବେ ସାର୍
हाँ भाईर झीर बाहागर अच्छी ना
ଆଚ୍ଛା ଆଚ୍ଛା
sir ଆସିଲେ sir
ସାର୍
ଦେଖା
ଆସନ୍ତୁ
ହବ।
ସାର୍
हाँ ठीक अच्छी एक्चुअली मु कौन करती छी कि मो मैटलैब टा थिला किंती उड़े दीची पुणी मते
ओहो
ताको लोड करियो पड़ची बुझिले कि मैटलैब टा से भितर जदि नहबो मते ठीक टाइम देबे तांकर बुझिले कि जेतेले सेकंड हाफ रे
ଆଜ୍ଞା
ଆଜ୍ଞା sir
जेकोसी गोटे टाइम टिके देले मु से स्टूडेंट को कहबे दी मु सेमान को टिके व्हाट्सएप करे देबी
ଆଜ୍ଞା
ଆଜ୍ଞା
मैटलैब रो
sir
काहे कि ना मोर एटा किंती उड़ी जे मु जानिनी मु एबे लोड करची तेणु इन द मीन टाइम्स मु तांको सेटा सपोर्ट कर परिबेनी हला ता टूल
ଆଜ୍ଞା
बॉक्स
sir
टा
ଆଜ୍ଞା
लोड करिया को 2 घंटा लागि जाउची
ଆଜ୍ଞା
तो
sir
मते जेकोसी गोटे फ्री टाइम देबे आजी हला
ଆଜ୍ଞା
sir sir
आफ्टर माय ओवर पूरा कंप्लीट होला परे मु सेता ताको सेठी ट्यूटोरियल टिके दे देबी ओके
ଆଜ୍ଞା sir
तो मु कोन स्टार्ट करबी
ସାର୍ ହଁ ସାର୍ ଷ୍ଟାର୍ଟ କରିବା ମୁଁ
ना टिके
just
सुन जाउची मोर हां टिके नियो तो टाइम टिके नै तो देखिए
sir ଗୋଟେ ମିନିଟ୍
हां हां टाइम नियो
पंडा सर शुड वी स्टार्ट
हां आई कैन स्टार्ट आई डोंट हैव ए
Okay.
प्रॉब्लम
Good morning to one and all. Today we have very young and energetic personality, Professor Sudhanshu Sekhar Panda from IIT Guwahati.
सर सर आई पटना सर
IIT Patna, sir. Sir has a very vast teaching as well as research experience of 23 years. He has very vast subject expertise in mechanical engineering, like machine design, composite material, manufacturing technology, and especially advanced analytical methods. His research area includes tool condition monitoring, soft computing, metal cutting, and machining, industrial application of soft computing techniques in machine, design of experiment, statistical modeling, biomachining, and sensor calibration. Now he is handling two research projects, drilling of human bone for minimal bone tissue injury and Second one is monitoring of heat flow phenomena of a low freezing material during continuous casting. He also acting as the editorial board members of different journals like Journal of Mechanical and Industrial Engineering Research, IJQM, and a member of MEIJ. Now, two students are doing their PhD work under the guidance of Professor Ponda, and he has also published two PhD students. He has a very vast publication in different international journals and reports, more than 20 numbers. He has delivered talk in different national and international conference and published more than 10 numbers of research papers. Now I heartily again welcome Professor Sudhanshu Shekhar Panda to preside the session. Today in the 12th lecture of this FDP, he is going to deliver the subject and enlighten the knowledge in the field of fuzzy logic and its application. Now I request Professor Panda to preside the session.
Okay, so good morning, all of you. Good morning, sirs, and Professor Chittaranjan Deo and Dr. Santosh Kumar Saul.
Sir.
So I welcome all the candidates here for my presentations. So I will take you to my topics in which I am going to highlight and will give you some brief information is regarding fuzzy logic and analysis. So I'll share my slides now, and I hope that if in between if I'm loading I'm loading this MATLAB's tutorial, MATLAB's links simulations. If it will be completed, then I can show you some workshop hands-on practice of how to handle this fuzzy logic using this MATLAB. So I'm sharing the slides now. No, I'm sharing. You can check your presentation screens now. So you can see the slides. Can you see my entire screens?
Yes, sir.
Yes, sir.
What is the problem? To get the full screens? I think why I'm not getting this full screen here. Okay. So today the topic of presentation is fuzzy logic and analysis. Here, what I'm going to discuss is regarding the application of fuzzy logics and most of the part how to handle this fuzzy logics. First, introductions. Second is process monitoring, in which we are implementing this fuzzy logic approach to a different manufacturing aspects: machining, welding, rolling, USM, ultrasonic machining, EDMs, as well as grinding, and so many other techniques. Even in one of my works also by machinists, there also I have implemented the same things. So what is the case is that why we are going to implement this type of approach, logic approach for process monitoring. So the part is coming, what is the need of monitoring the processes? So that's why that is the third point that I'm going to take care. Then next is signature analysis, that is not at all required in case of fuzzy logic, and the fuzzy logic approach. So in the fuzzy logic, that's a lots of information that we will gather. One is classical sets or crisp sets, fuzzy logic, how the fuzzy logic is used, generalized fuzzified application, expertise fuzzified system, case study, material toolbox. So first, when you are discussing about the case of introduction, where we are actually implementing this particular type of soft computing approach like fuzzy logic or any other artificial neural networks. Okay, so all this soft approach we are implementing in our process monitorings. Normally, what happens when you are saying that human beings, okay, human beings, they used to get their comfortable lives. Okay, so when they used to get the comfortable life, if you look into the earlier cases in the old age, we used to plug the apple or something from the fruits. What is the approach that we are using? We are using only the human efforts. We are either going to the top of the, we are climbing to the trees and we are plugging it. Later on, with the later on with the improvement or the gathering of the intelligence in the human bodies, what happens? He started thinking how to more comfortably we can plug the this kind of goals or fruits from the trees. They use a stick or something like that. Okay, so the sticks of plugging the apples or fruits from these trees is something he utilizes less effort to get the things done. Get the thing done. So that's why this particular case we are saying main machine and welfare. That means this particular welfare, for the welfare purpose of human beings, we are using the human effort as well as you are using the natural available material to get our desiredness, like comfortability. We are getting through our cars, through our the different equipments, through our the different like utensils that we are using. And here we are getting this welfare by help of these two important things. One is the naturally available resources, second one is human efforts. But most importantly, to reduce the effort and to minimize the times you are using the tools. Now the tools is what, like stick that you are using, so that our effort will be reduces, you can get the thing done. That means we can reach our goals. Okay. So these tools is nothing, what we are saying is the processes. So many kind of tools that we are using to develop our desire, requirement or a goal to achieve our goals. These tools, how to handle these tools? What are the tools? So many things. All the kind of process that you are using, like cutting out of the materials to a desired shapes. You are using machining operations to improve the property. You are doing some annealing operations. So all this process is a kind of tools. And this tool is what? Our important experts, and we are going to monitor the tools so that we will reduce minimum or we can minimize the resources, we can minimize the effort, or we can minimize the energy, we can minimize the monetary, we can improve the productivities, we can improve the goals in terms of its quality, in terms of its strength, all these things. That's why this tool to be monitored properly. And this monitoring approach, oh, it is not moving. So like this one of the case is like we are from the input of the resources, you are getting output. That means you are adding the value to a raw materials, which is there in our hands to create a nut and bolts. And this is a what we are saying, this is a kind of process. We are giving some value addition. The different processes that we are taking care is, one is a temperature effect of the tools that we are going to take care. How, what is the effect of the temperature on the tools and about the jobs when you are doing some kind of process like machining operations, we have to look into the effect of this temperature. Now the temperature case is coming. And we are monitoring, you are using this subcomputing approach, okay, like a fuzzy approach. If the temperatures we can detect, we can collect the information exactly, we can take the data, we can use, okay. And if some cases, if you cannot able to collect the information properly, but through some vague way, we can collect the information of the temperature by looking into its color. There we are using the approach of fuzzy logics. Okay, so how this temperature affecting the machine surfaces or something. So now, and different cases are there. We'll jump later on, come to the case of the fuzzy logics. We'll jump directly onto the fuzzy logic, then we'll look. So needs of monitoring is any variable that can be monitored. However, the purpose of the process of monitoring is that you can react early to the bad or unusual operation. So that why we are using this approach, so that before going for a failure of the such cases, we can prevent it. Prevention is better than cure, that we used to say. So now we are monitoring because we can prevent it. We can prevent before it get damaged. Okay, so that whole of the effort to get our goal or to reach to the objectives can be defined properly. Okay, so that's why this implies that we should monitor the variable as soon as they become available, preferably in real times. So they are more suitably than variables that takes a long time to acquire. So we should not have to wait to end of the production line to find our process was out of statistical control. So that's why when we look into the case of some kind of approach, different type of processes that you are using in any kind of process, depending in parameters that you are actually having a control. So you can have a control over the parameters. Now, if you know that this particular range of the setting and we are playing with that range of settings and we are getting our job done. For a case like if a particular product is being taken into the lathe machine and doing some removal process, material removal process, our intention is to get a better surface finish there. Our deviation should not be there, dimensional should be correct. Then what we are doing, we are playing with the process factors, okay, or the different parameters that actually influencing the roughness or the dimensional accuracy of a product. There, what we are doing, this process to be monitored properly. Sometimes it happens that we know that any kind of dimension that is there, like if you see that there is a diameter of 8 mm, we can mention that this diameter, because it is something that you cannot get exactly 8 mm, it will be having some tolerance limit of the dimension of this diameter will be 8 mm plus minus some tolerance. That tolerance is our requirements as per the custom requirement we are giving. That's why whenever we are defining any product, anything, we are defining with its mean value and its upper limit and lower control limits. So upper limits and lower control limit, whole process has to follow. Normally it should be distributed. That's why it can meet to that design requirements. Now, if it goes beyond that limit, that indicates that some unusual thing is happening there. And that unusual thing is in your controls how you can do it. Like the bottling of the thumbs ups or something, some cold drinks, we know that there will be 300 ml bottlings is there. Plus 300 plus minus some range that will be desired for you, upper limit and lower limit. And beyond that limits, if in a batch bottles having beyond that limits, okay, that indicate that in the same processes some unusual things are going to happen, and that unusual things happening, that's why you are rejecting whole batch, whole product. Okay, so that is your idea how to handle it. So when and what and when to mentor. So you have to do what? You detect, then you diagnose it, then you predict. After predicting, then you take care the proper measurements. Now you will see in the diagnosis systems, okay, you can see a danger level there. There is a case of danger levels. So when you are collecting the signals from here, okay, and the major signals that you are detecting it from a nucleus of or from a chimney, okay, some kind of signals, maybe something else, heat or something like smoke that is being ejected, and you are taking its information. You are taking its information through sensor, and through along a time domains, you are collecting the whole of the data. From there, you can able to analyze whether it is within the signal are coming within the band, within the limit or not. And accordingly, you can say that if something goes beyond it, you can say that there may be chance of getting a fault. The fault may be of different way. It may happen because of some other some kind of regions. So that regions may be a number of regions, and each region has to be sorted out by you. So that's why what are the regions is something you are looking into a case of cause effect diagram there. Okay, so failure mode of a case study is like failure mode of a main shaft. What is the reason? It may be because of fracture, or it may be because of deformation. If it will be a case of fracture, what may be the reason of fracture? It may be high cycle fatigue, it may be corrosions. If it is a case of deformation, what may be the reason? This may be the reason. So likewise, like fishbone diagram something, if you are finding out a particular cause of fault, you start on asking the question and sorting out the things, why this is going to happen, why this is happening like this. And likewise, a fishbone diagram will be generated. So you, for a particular single question, you have a number of queries, and each queries has to be identified and has to be sorted out. Okay, so now from so many queries, you can say that these 4 to 5 queries are not that much of affected. It's very least significant. But these many queries will be mostly significant to affect these particular kind of failures. That's why you have to give emphasis on that. So that's why we are creating some kind of histograms to generate this. So leave this. So you are actually, the main idea of compounding is to what? You are doing some kind of modelings. Okay. You are replicating like a brain, human brain's minds, and you are modeling the whole of the processes. Okay, and whole of the processes you are modeling by help of collecting the information from the real set of test data. So that's what you are doing is learning by experiments. What you are doing is that you start on learning it, you can go for the testings, then if it is matching, then you can say that yes, I have learned it like a small child started learning. In the same way, you start learning when you satisfied that yes, I have already know the way in which I can able to predict the things. Then at that point, you can use that model to a new set of fault detection or new set of data or information where it can able to give you realistic approach, realistic values that yes, this is happened because of this, you can able to say. So the case is fuzzy logic is a kind of soft computing techniques where you can use this imprecise information which is not available with you to give you a correct answers. Okay, so this something fuzzy is somewhat, you can see a kind of cognitive models where you can able to handle imprecise data there. So a set, first of all, when we are looking into a fuzzy set, we have to discuss about. So am I Am I audible to you? Am I connected? Huh?
Yes, sir. Yes, sir.
Okay, okay, okay. So, set. What is a set? Set is defined as a collection of objects which share the certain characteristics. So, one is classical set is a collection of distinct objects and set of negative integers, set of persons with a height less than 6 feet, days of a week. All these are the kind of sets. So, each individual entity in the set is called the number or the element of the set. So, classical set is defined as in such an inverse of discourse that's split into two groups. One is member, another is non-member. So if we look into a classical set, so before going for fuzzy set, we have to identify what is a classical set and Cripps sets. So classical sets, one is member, another will be non-member. These are the way in which you are defining the sets. Now, if you are defining as a set, what is this? 2, 4, 6, 8, 10 are the number. If A is a set, X is a prime number less than 20, so you can define the set there. What is the prime number? Accordingly, you can define that number. And what are the other number that is available will be non-members. So if you will see what about the values that is coming here, A, X is an element belong to P and Q. Then what we are saying, if all these are coming into the case of set, we are defining what is the membership of that set, value 2, that means it will be 1. What is the non-member? If it is a member, then its membership will be 1. If it is a non-member, its membership will be 0. In that way, we are defining. So similarly, null set is there. So Cripps set means either it will be defined as it is a member or it is a member. It is true or it is false. In that way, we are defining it. So for a Cripps set A and B containing some element in inverse X, the notation used that X belongs to A, X does belongs to A, X does not belong to A. This is the two way in which we are defining the classical set. So in the classical set, you can say that one of the set will be complete subset of B, or it will be as equal subset, or it will be contained with the B, or it will be equal to B. So A equal to B means A subset B, B subset O. All these are the operation of the sets or Cripps set that we have already identified. So we have followed with certain kind of rules. What is the union of these? What is the intersection? What is the complement, difference? All these are and different properties like commutative, associative, distributive, transitory, identity, all are known to you. What is the set and how we are identifying. And these are the different kind of Cripps set that you are defining. So properties of classical sets. Okay, so what we are doing for a classical set will be defined by the values 1 or 0. 1 or 0. If you say days of the week and weekend means you are defining either Saturday and Sunday will be the weekend. That will be the two value which is having membership 1. Other are not coming under the case of weekend. So that's why its membership will be 0. So what is why fuzzy set we are saying? In the real world, there is much fuzzy knowledge. The knowledge that is vague, imprecise, uncertain, ambiguous, and inject, and is a probabilistic nature. So human thinking and reasoning frequently involves fuzzy linguistic origin from the inherent. So it is somewhat kind of fuzzy means somewhat it is not a Cripps, it was somewhat vague information. If it is vague information, you cannot define your membership like 1 or 0. It will be ranges between 0 to 1. It may be continuously ranges. You can give a continuous form. And fuzzy means vagueness. So that has been that fuzziness occurs when the boundary of the piece of information is not clear to you. So defined by the Jade. So what you are saying, it is a membership. So fuzzy set theory permits the gradual assessment of the membership element set described with the aid of membership function valued in the real unit between 0 to 1. So what we are doing in the real world problem, there are different uncertainty, ambiguity. Whether it will be when we are going out, we cannot able to say that how much wind is flowing. You cannot give you exact speed of the wind there, unless otherwise you are not going to measures. So for a layman or for most of the cases, what we are doing, we are just by bag, we are just saying how tall he is. You cannot define that he is 5 feet, is a tallest or like that. So that's why you are making some kind of membership with for the tall, for the short person also we have some kind of memberships where we can define our ideas. So uncertainty and ambiguity that is there in our real worlds. Okay, we are collecting that one. all imprecise data to the fuzzy logic to give you a proper decision. Otherwise, it's difficult. A case say, suppose you are doing machining and chips are coming out. Okay, when I am saying you that without measuring the chips, just define me which chips is more thicker or something like that. So by visualize, you can able to identify the chip and you can able to define that is high thick, more thick, very thin chip, thin chips is coming. Okay, it is in between thick and thin. Like that way, you are just giving your information, just looking to the observation because you don't able to collect the information exactly through sensor or something. In that case, what you are doing, you are defining some kind of thickness. You are defining the width, thickness of the chips that you are defining by your own way. So it ranges between 0 to 1. So fuzzy set theory. A fuzzy set is anything that allows the membership to have a this show. If you are saying about the case of days of the weekends, now both Saturday and Sunday are coming in case of this set as a membership one. But here, if we are looking to case of fuzzy, we are saying that Saturday will be the degree of membership is 1. Sunday, we are defining it somewhat lesser than 1. And if you see Tuesday, Monday is just near to the weekends. That means Saturday and Sunday are coming near to the weekends. Okay, if you are defining Saturday is the weekend at least one membership, so one day, Sunday and the Monday, that too we are giving a membership of 0.8. Whereas Wednesday is far away from the weekend, Tuesday is somewhat approach to the weekend, so that's where this membership value continuously is very like this way. In that way, you can say. So fuzzy logic capable of inherent praise forget so a logic based on the truth and false is sometimes inadequate when describing the human reasoning. So fuzzy logic uses the whole interval 0 to 1 to describe the human reasoning. A fuzzy set is any set that allows its members to have a different degree of membership or membership function. The degree of membership or truth is not the same as probabilistic. So fuzzy truth is not likelihood of the some event or condition. Fuzzy logic derived from the fuzzy set theory dealing with the reasoning that is approximate rather than precise, deducted from the classical predictive logic. So if you see this imprecise information like slightly, quite, very, it was a somewhat a kind of linguistic approach. If you see an example like this, fuzzy logic is not a vague logic, but some logic for dealing with the vague concept. So if you see that if it is sunny and one today, I will drive fast. Now this is the way a layman used to say. Okay, if it is sunny, you don't know sunny means how much degree of membership that you are giving to the sunny. War that you don't know. So that's why you are defining in terms of membership. If you see like if one person is there, Nick, whether Nick is honest, if it is a precise information that you can see true, that means you will be defined 1. If it will not be honest, 0. But the honest can be defined on your own way. You can give a degree of something. It's honest. So likely extremely honest, very honest, sometimes honest, extremely dishonest. So this is the way you can define your degree of approach of honest, so that you can say. So this is a layman approach, and this is what 10 is somewhat censored approach. You are collecting the data and you are trying to do, but this never happens. Like temperatures, you can say freezing, cool, warm, hot. This is a linguistic way you are defining. Cloud, the overcast, partly cloud, sunny. So this way you are defining the case. So if it is sunny or something, you are creating your own speed. You can so say slow, fast, very slow. Like that, you are defining your way, own way. This is what a vague information coming. That's why you are approaching this fuzzy. So fuzziness means vagueness. Fuzzy set theory is an excellent mathematical tool to handle the uncertainty arising due to vagueness. So understanding the human speech and recognize the handwritten character are some common instances where fuzziness manifests. Okay. So that's why. So what this particular of the speech that you are saying, and based on your speech, you can see Google's are writing something, speak something, and they used to recognize. Okay, so this way you can write handwritten also. Okay, so in that way, through your speech, you can somebody can able to recognize the handwritten. So all are interconnected. Okay, so that the information, if it is a vague information, then you can able to collect the real and you can correlate. This is what you can say that this is a fuzzy is something giving you relationships, input output relationship. If the information are vague to create an exact solution. Is water colorless? A question is coming. The answer is this: the yes, true, no, false. Okay, true and false. That is a Krebs. If the yes true is recorded 1 and no is recorded 0, so the statement 0 1 is a situation. Such logic demands binary code of 0 1 types handling is termed a Krebs in the domain of fuzzy set theory. On the other hand, consider the statement is RAM honest, similarly yes no. Okay, so this case can be treated as so wherever there is no vagueness, you can see this what water, there is no vagueness there, so you have to define either color or colorless or color not colorless like that way. But if some type of properties which is not actually is a vague something, if, unless otherwise you will not censor or you do not capture through this, then you cannot have to detect. So like RAM, honest or not, it can be it cannot be a binary coded. It can vary based on the person to person. So that's why, for instance, extreme honest to be accorded a value 1. This is what I have discussed last. So you see, water is a colorless, it can be treated in a fuzzy set, but is RAM honest can be treated into a fuzzy set. So word like young, tall, good, or high are fuzzy. There is no single quantitative value which defines the term young. For some people, age 25 is young, and for others, age 35 is young. That depends upon your perception. If the question is given to you, you create your own relationships. The concept of young has no boundaries. So age 1 is defined young, and age 100 is defined not young. So age 35 has some possibility of being young and usually depend upon the context in which it's being considered. So now if you see the case of height, okay, what is this, tall or not tall? Accordingly, you can define your way in which if you see that is not tall and tall, it's a kind of Krebs where you are saying between this particular height 1.8 meters to this meter, that means not tall. It is not at all tall. That means if it goes beyond 1.5 meters, something like this, 1.5 meters, suppose this is the line, you can see the cursor. If it is beyond 1.5 meter, it is not at all tall. That's why it is now coming. Now between 1.5 to 1.8 meter, 2 meters. Okay, so what happens? The tallness goes on increases. That means 1.5 meters to 2 meters, it can approach to tall there. That means from not tall to tall, it takes times. And it takes times to reach to this 2 meter, then it will be treated as tall. So that's why this degree will be now goes on changing here. So this is the graded or the membership that you are defining as per your own way. In examples, if temperature is 30 degree, then switch on the condenser to 80%. of a rule based system without fuzzy logic. ठीक है, exactly तुम data दे रहे हो and then accordingly you are seeing. If the temperature is 30 degrees, switch on the condenser to 80%. This is not a layman. When we are discussing with ourselves, when you are discussing with our colleagues or something, you cannot say speak on this particular through the information approach. Okay, if the traffic is having 20 cars, then extend the green light by 20 seconds. This is not the correct way you cannot do. What is the approach actually? In reality, in the world happening, if the temperature is high, then switch on the condenser to high. If the traffic is heavy, then extend the green light to longer. This is the right way in which we are actually speaking, and we are realistic incidents are happening. Okay, so like our washing machine, fuzzy based approach through which the motors are running. Okay, we have speed limit, the low, medium, high, like that way. So accordingly, it started running. So most of the cases, if it is very dark, you have to, the speed should be higher, okay, or slower, and something else, and turning of the cloth up and down should be higher. Like that way, some type of operation that's happening in case of the washing machine is based on fuzzy logic approach. So based on this, yes, you have an idea about the clip set. In the similar aspect, we can have a fuzzy sets which two different, because you are creating a relationship. You have a two input data, so you have a two input fuzzy. How to make a common goal from that two fuzzy sets. That way we are using different kind of rules to build up this A union B, A intersection B, and you have all this rule that as similar as like grid sets. So this is what we are getting. So different fuzzy sets are there. So I'll say you how to handle this, for how to collect the fuzzies. Two fuzzy sets are there. How can you do the sum to the intersection union of and the product of all the fuzzy sets with examples. Let's see. If we have a fuzzy sets I, that's why fuzzy sets, each member, these are the member A, E, X, Y, I, and T are the members, and each member are given degree of membership like this. Okay, so that means if you see for case of temperature also, high temperature, low temperature, medium temperature, like that way, different kind of temperature are there. In that way, the membership are given. Okay, so this is the case. If all these elements F, X, Y are having a membership, this another fuzzy sets having the same element with a different membership artist. And how we are doing union? Union is the maximum of these two membership value, maximum of the membership value of the two members. Okay, like for F, we are maximum membership that is coming. So in that way, you are making a membership here. Union. Intersection also you can do with a complement is there. So complement means from a 1 you are minus 1. So that means member F with value 0.01, that is F complements. If this is 0.01, here this is 0.4, and you are doing an intersection, that means you are choosing the minimum of the membership of the both. So accordingly, you can do the intersection. Now, if you see opposite sets A and B defined on the interval 0 to 5 in the real number by membership grade function this, so you can define a membership with a certain kind of algebraic formulation also. This type of memberships you can do through, this is what we can say a continuous way of evaluating the membership. So you can give your own grade of membership. You can do the Gaussian membership, you can do normal distribution membership. Based on the data, input data, you can create your membership with certain logical interpretation that it is correct for you. So you can have a membership, continuous membership. How it can vary? It can vary like this way, like this way. This is your triangular memberships, square membership, rectangular membership. Any type of membership you want to do, you can do it. So if you see the membership function, you can see this is the case of union. So maximum of the membership that you are choosing between A and B. Similarly, intersection, only minimum of the membership that you are choosing. Okay. So fuzzy set and the membership. Suppose if you want to link, fuzzy linguistic variable are used to represent the qualities spanning at a particular spectrums like temperatures. You can say the temperature, it can be very freezed, cool, warm, hot. You can go beyond that also. That is your task. You can look into your aspects, how much you are giving the kind of linguistic variable that you can define. Can be freeze, cool, warm, and hot. So membership function question, what is the temperature? Answer is it warm? It is warm. Question is how warm it is. If this is the way, you have to finally what? From the vague information, you have to give an exact information that you have to create. So if you see the freezings, you can see the membership. You know that the temperature goes of a water or something, it goes from 0 to 100 degrees centigrade. That's boiling points. Now if you freezing, what you are defining freezing as per your aspects is that within 30 degree, we are saying that 30 degree Fahrenheit is somewhat below how much centigrade? How much centigrade it becomes? 273 degrees centigrade. 273 Kelvin is equal to. So in that way, it is going beyond the negative direction. Okay. So less than 0 degree. So what is going to happen? That means it's cool. Then when you are going and coming back to this 50, that means you start that freezing. That means there will be no freezings. That's when it become ice. That means below 0 it become ice. After that it doesn't maintain ice. But you can say that it is cooler. That means you are going from freezing to cooler. So freezing to cooling condition you are going, and it started from 30 degrees centigrade and it started increasing to up to 50 degrees. This is the way where your freezing goes downward, that is membership goes. When cooling started increasing its membership, freezing membership goes downwards. So that's a, you can have an interconnection, that is a position where both the membership will remain same. That's your aspect in which you can develop your membership. So now cooling goes downward, at that times warm condition goes increases. When warm is going downwards, at that time hot goes increases. The hot linguistic term goes and increases. Okay, beyond that you do not have any linguistic variables, so you are not depending. Now this is the your approach, your concept, how you are defining based on the degree of, based on the realistic data. That how you are defining your membership value. What is your overlapping? It can have a overlap 20%. You can have a 10% overlapping. You can have 90% overlapping. You can go like this way also. So you do not have a controls. It's based on your approach. If question will be given to you, you have to give the answer. And how precise you can do, that is what normally playing with this data, you can get ideas. Okay, I am wrong this steps. I should have to do this way. Now I am right in this step. So you know what type of membership we are doing. We are using like triangular or trapezoidal or Gaussians. Okay, and how much overlapping we are giving. When you are feeding these data like freezing, how much the range we are defining for case of freezing. All this is a hit and trial procedures. After playing with a particular case, you can get the idea that yes, this is the correct way in which my prediction will be appropriate. So at the first times you cannot say that my results will be accurate. So it's depend upon you. So now based on this particular case, if I will define 36 degree Fahrenheit, where it will be placed, it will be placed here. So you can say membership of freezing is higher, cooling is somewhat lower. Higher means 0.9. For case of cool, it will be 0.1. But other cases like warm and hot, it do not have a membership. It have a membership 0. Similarly, it is 30% cool, 70% freezing. So in that way, you can define. So 36 degree Fahrenheit means 30% cool and 70% Fahrenheit. 0.7 and 0.3. That is the membership we are getting. Now fuzzy memberships. So how you are defining a set with value with a member X along with a membership value of that, which is belong to the inverse of discourse X. So now if X is a fuzzy set having G1, G2, G5 with the reference of the student, let A be the if these are the student sets, okay, and A be the fuzzy set combining the smart student, where smart is a linguistic term that we are defining the group of the student, how we are defining the smartness for a fuzzy set. That means this group of the student bearing a smartness 0.4, where the degree of membership of group 2 student is 0.5, higher is 0.9. If this is the case, this is the way in which we are defining. So through fuzzy set model vagueness, it need to be realized that the definition of the set varies according to the context. So membership functions, you understand how to do the membership, like fuzzy set and membership, how defining the temperature. This is another way of membership that we are defining the temperature with the fuzzy sets. Now, if you use a membership of Gaussian membership also, you can define this Gaussian membership with some mathematical equations. You can have a different membership, you can see. Now, if you see a case of people, age of peoples, 0 to 10, 10 to 50, 20, 30, 30, 40, 70 hours, you can create a membership based on your approach. So young, we are defining between 0 to 40 years. See, middle age, you are defining between 32 and 50 years. And you have some overlapping where you do not have a overlapping between middle to old. That is your perspective, how to handle it. So fuzzy conjunction and disconjunction. So if you see union of two fuzzy sets, we are taking the maximum memberships. You see, A and B are two fuzzy sets defining that in this group. So we are defining, and if we are creating a union of these fuzzy sets, we are getting a value of 0.75. For intersection, if you are defining for a particular values of particular number where A contains a membership of 0.375 and B contains a membership 0.75. So minimum value we are choosing here for this concept. So A intersection B 0.4, B is 0.2. So this way fuzzy and value are being given minimum value. Now fuzzy control. This is important for you. You are controlling the fuzzy sets. So fuzzy controls that combine the use of fuzzy linguistic variable with fuzzy logics, like speed controls. How fast am I going to drive today? It depends upon the weather, discongestion or conjunction. So if you have a temperature of different degrees given here, freezing, cool, warm, and hot is one of the input that is controlling your speed. Next is temperature is given, one of this. Cloud cover is given to you, that is sunny, partly cloud, and overcast. And you know about this, the percentage of the cloud cover there with the membership. So if it is 100%, that means it's going to overcast. Less cloud cover percentage means there is a sunny here. And the values that you are defining is your upper spectrum in which you are defining, and accordingly the membership also you are defining. Now, rule is that your speed also you are defining. Speed is slow, you are defining like this, and fast is defining. So beyond a particular miles per hour, you are defining it fast, and slow is this. And they prospectively they increases their membership where it decreases its membership. Now, based on this input and output, so you know that there are two input and this is the output of your vehicles, and you are defining a rule-based technique there to do. What is the rule is that if it is sunny, logically if you interpret, if it is sunny and warm, that means धूप है and warm है, तो क्या कर सकते? बहुत fast you can drive it. This is the correct way. You can go fast. If it is cloudy and cool, you have to go slow. If it is not only two rules, you can define your rules. So you can have multiple rules. But this is a rule when you are defining, it should be logically fit. If it is cloudy and cool, you cannot go fast. This is a definite case. Okay, so you cannot do that. So you have to create a rules based on the proper logical interpretation. Driving speed is a combination of output of these two rules. Now the case is coming. See, am I audible now? Am I audible? What happened?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. So this see the speed calculation we are doing. How fast will I go if it is 65 degrees? Now the data is given to you. You have vague information with you. Now for a correct data, the correct interpretation, you have to find it out what is the final results that you have to do. So how fast will I go if it is 65 degree Fahrenheit, 25% cloud cover? If something like a exact information to give it to. So 65 degree Fahrenheit, we have to calculate the membership of each of the cases of temperatures. So 65 degree Fahrenheit for cooling it is coming, for warm it is coming, and as well as for freezing it is coming. Okay, so you have a lots of membership for the 65. 65 is coming here. So it is actually coming for cool and warm, not for freezing, so not for hot. So we have two membership, one is 0.4 and 0.7. 25% cover of the cloud percentage. So you are getting sunny is coming 0.8, cloud is coming 0.2. Two membership you are getting. Now the case is coming, rule is what? If it is sunny, it what? Drive fast. Sunny. Sunny is how much it is coming here? 0.8. And warm is coming how much? Warm is coming 0.7. So two membership is there. So if it is sunny and warm, that means you are choosing the minimum of this. That means intersections. If it is sunny and warm, fast speed is fast. That means fast speed value of membership 0.7 based on the rules for a particular data set. You are getting speed, slow and fast is 0.7, 0.2. So now 0.7 and 0.2 indicate 20% slow and 70% faster. If you want to define the 20% slow, 70% faster, and you have a wide range of speed here, what is the value of exact speed that you want to find it out? You have to go through a centered methods. Okay, so when you are going for a centered methods, 20% slow, so you know that slow 25 में slow is completely 100% is there. So 20% में कितना हो रहा है? Similarly 70% में, so 75 में 100 पूरा fast means 100%, that means fast. That is the degree of membership 1. So 75% में 70% में how much fast you are getting? You can have now find it out the centered method or average of this. So 20 plus 70 by 100. Finally, weighted speed is you are getting 63.8 miles per hour. So a particular data, and from the fuzzy linguistic approach based in your way, you know that at 65 degree Fahrenheit and 20% cloud, you can go with a speed of 63.8 miles per hour. Okay, so 63.8 miles per hour means somewhat going towards a faster side. In the same way, Cartesian products. So okay, so there is a relationship. I'm jumping it out of this. What is this relationship? How to get the summation? So summation we can see A plus B. The simple way you are defining A and B summation, that is you are choosing the maximum out of this A plus B. So all are having element values. Yes. Okay. I have another question.
Slide is not visible.
Slides are not
It is
visible.
not visible.
No,
Yes.
no, on shared हो गया, on shared here. Okay, let me share again. Hello. Okay. Now
Yes,
sharing.
sir. Yes, sir.
So summation like each elements A and B having the C element A, B, C are there, having different membership of this, and what you are doing maximum of this. Union C. You have a membership because you see this fuzzy set is nothing but a relationship between 1 to 3 and ABC. That is a relationship between 1 to A, 1 to B, 1 to C, and each having a membership of this. 1 to A relationship is 0.3, 1 to B is 0.2. In that way, you are creating a real membership here. So in another fuzzy sets, you have a relationship of the same member, 1, 2, 3, and ABC. The relationship of the fuzzy membership are given here. Now, if you want to do a unions, what you are doing? You are choosing the union means maximum of this. You see, maximum of this. All the membership. So you have a relationship of each member between 1 to 3 and ABC, and you can do a relationship between two fuzzy set by choosing the maximum of this. 0.3, 0.3 आ रहा है, यहाँ पर 0.2 0 है, तो that's why you are getting 0.2. So you are choosing maximum out of this. Similarly, intersection you can choose this way. Minimum of this. So wherever there is minimum, we can choose the minimum of these relationships. A complement also in the same way you can do. If there is a real MR, is a memberships, complement will be 1 minus something. So everywhere you are finding the 1 minus something. A scalar product is there, which is value ranging between 0 to 1. You can multiply that scalar product, you can find it out what is the value. Like 0.5 is a scalar that you are multiplying. So you are multiplying it and finding out the values of what is the membership. Now, if you're doing a product, now product will be max mean composition. That means what? Product when we're doing, that is a max mean composition, like rule that you are creating. Two rules you are product. If these are the two rules. If it is hot, and this speed is fast if it this row, and if it is very cloudy
Sir,
and
please
full.
make it full screen, sir.
I made it full screen, no? Not it soon.
No, sir.
Okay, why it is not showing? Again, I'll close it. Now I'll make it full screen. Can I? Is it coming full screen? It's coming full screen.
No, sir.
So I have to stop again. I have to do it. I'll do it again. I'm again sharing. Let's see. Here enter screen. Let me see. So select allow. Enter screen. Allow. Shift. Now it is coming full screen.
Yes, sir. Yes, sir.
Okay.
Sir.
So now when you are doing this product, you see, this is what, if you want to find out the relationship between A and B, multiplication of product A and B, this is a membership A and this is a fuzzy set A, fuzzy set B, having a members, and each member having a fuzzy membership here. A2A is 0.2, A2B is 0.5. In that way, the membership are given. Okay, for between two fuzzy set A and B, when you are multiplying A and B, it will yield a product C, and C will also contain, what are the elements? It will also contain 3 by 3 matrix. So 3 by 3 matrix means C11, C12, C13, C1, like that. So if you want to calculate the value of element C12, what we are doing is first row multiply the second column of the other fuzzy. So what we will get it? C12, you will get, what is this? 0.2, 0.50. So 0.2, 0.50 here is there, and this is the column that you are doing 0.1, 0 and 0. So if you want to get a product of these two, what you are doing? You are choosing the minimum of these two. So when you are choosing 0.2 and 0.1, it is coming 0.1, 0.50 you are getting 0, and this is coming 0. Now out of this you are choosing maximum of membership, that is coming 0.1, and finally you are getting a product value is 0.1. This is what we are implementing in our rule-based systems, C12. So similarly C11, C13, everything can be calculated based on this. If you want to find out C13, it is the same way you are finding out C13. So finally we can get a value of C like this. This is the new max min composition of this product. Where you are using this we are using in Mamadin model, Suguna type of models. So we are max min composition we are using actually normally in Mamadin model. Suguna model you are using some other kind of fuzzy relationship. So this particular product is nothing but a composition analysis. So what we are doing here, for these two relations, let us make a composition named T, where R and S are two fuzzy sets are given to you. X, if R having a relation x1, y1, x1, y3, and x2, y4, y1, z2, y3, z2. And what we are doing, there are two common forms of the composition relationships. That is max min compositions or max product composition. Then we can multiply R and S in that way so that you can get a product, that is max min composition. I have told you how you are developing C from A and B. In the same way you have a product composition, that is the another max product composition, that is the Sugano models. We can able to evaluate its output also. These two are used for the rule case. When you are going for a rule case, there you are actually implementing. See, you are generating this to this and this to this relations are there. If this to this and this to this relations are there, then you can generate a relationship between this is known as composition. Now, if you see is a max min composition relation matrix between R and S would be expressed as this. If you are having a product, you see R is a fuzzy set having a relationship between X1, Y1 memberships, X1, Y2, X1, Y3, X1, Y4, and you have a matrix like this way. S having a relationship between Y1, because this because this contains y1, y2, y3, y4 and having another relation between z1, z2. So finally, when you are yielding a value of t, which is nothing but product of r into s, so that's why indirectly what you are doing, you are getting a relationship between x1, x2, x3 and z1, z2. This is what your intention. If something going on, if there is a relation between x1, y1 and y1, z1, you can create a relationship between x1 and z1. And this is for case of a Krebs set. You see, all are given with 1, 0. So that's why it is a case of Krebs sets. And how we are defining this, you can see max mean composition, as like earlier case how we are defining in the same way. This row is how many? 1, 2, 3, 4 into 3 and 3 cross 4, 3 row, 4 columns and 4 row, 4 columns. So 3 cross 4 you are finally get. You will get 3 cross 4 and 4 cross 1, row 4 and 2, 4 cross 2. So 3 cross 2 you are getting. So you are finally getting a 3 cross 2 element. See, this is 3 cross 4, 3 row and 4 columns. This is 4 cross 2, that is 4 and 2 columns. So if you are multiplying 3 cross 4 and 4 cross 2, we will finally get 3 cross 2, the elements with different memberships. So this how you are defining this into this. So this into this multiplication करने you know how to find it out. All this you are choosing minimum, and out of this you are choosing maximum. Finally, you are getting a relationship. So this is what a composition relationship. If you have a value of a product, if you have a property sets having a relationship between the element 1, 2, 3, A, B, C, D with different degree of membership, as I told you, like fast, driving very fast, having the relationships. Fast means both are fast में है ना, fast and slow. Speed having a relationship with temperature and the something. Another one is your cloud percentage. Similarly, if you have a relationship of speed with temperatures, similarly, if you have a relationship of temperature with something else, you can directly relate your speed with that. That is what you are saying. Okay. So in that way, if we have a fuzzy sets having a membership relationship with the degree of memberships, and similarly these elements having another fuzzy set with another element's membership, so you can interrelate, you can compose it, you can find it out. So this is what you are getting it, relationship between these two, directly from your 1 to alpha, 1 to beta, and 1 to gamma. In that way, you can have a direct relationship. This is your max mean compositions. Just leaving it alpha cut, decomposition. Then what is the decomposition? Decomposition is what you are composing, you are creating a relationship. You used to find it out, you are decomposing through different techniques. Okay, decomposition means the relation R in the previous schedule can be decomposed as follows. So what is the way in which you are decomposing? So if you want to get it out, that what is the previous relationship, you can get that previous relationships. Now let's see. Let R be the fuzzy relation between two set x1 and x2, where x1 is the set of disease and x2 is the set of symptoms. Okay. So disease are what? Typhoid, viral fever, common cold. Symptoms are running nose, high temperature, and shivering. Now we are creating relationships. Now typhoid, viral fever, common cold, running nose, high temperature, shivering. And if you see the fever and its aspects because of which this typhoid is coming, there you are getting like running nose case is very small. That means very few cases we are getting. That's why we are giving a membership 0.1. Very high temperature coming in most of the typhoid case. That's why we are giving a high membership. In the similarly viral fever, high temperature we are giving high memberships. Shivering also there you are giving 0.7. Running nose case you are giving 0.2. But a common cold you are giving a high membership to running nose. That's why this is the relationship that you are getting between this and this. So what we are doing here, x1 0.2, x2 0.7, x3 0.4. Okay. Another relationship we are getting y1 0.5, y2 0.6, b2 fuzzy set depend on the inverse of discourse x1, x2, x3 and y1, y2 respectively. Then fuzzy relation resulting out of the fuzzy Cartesian product is given by this. If you have a composition like x1 to y1, you have a membership like this. How you are getting the membership, you understand about this case and running nodes, temperature and ceiling. Now, if you have a running nodes, temperature and ceiling with respect to some other factors with certain memberships, then how to relate this typhoid with that factors? This is what the real idea is. So now you have max mean composition, how to calculate, you understand this, how we are calculating. Between x1, y1 and y1, z1, we are finally getting a relation between x1 to z1, z2, z3 with the membership value. So composition relationship, you understand, by max product, what you are getting. So fuzzy inference, that is Mamadi. One of the most common use of fuzzy inference technique is called the Mamadi model. And inference process is performed in 4 steps: fuzzification of the input variable, rule evaluation, aggregation of the rule output, and finally defuzzification. So we are going for a defuzzification. So if it is a fuzzy control and if you have a relation A1, A2, two membership, input are there X and Y, output is given Z. Okay. Now you have a input X and input Y, you have output Z, you have two fuzzy A1, another fuzzy set membership A2, here B1 and B2. Similarly, you have fuzzy set C1 and C2. You can use this rule. If this is A1, X, any value belongs to A1 and Y is B1 for this particular case, then Z is equal to C1. Just like earlier case, what you are doing. If X is A2, Y is B2, Z is C2. The way in which the rule that you are creating, you can create it. Number of rules. And based on these rules, you see rule 1, you are giving a setting. So this rule 1, when you are choosing A1, when you are choosing B1, you are getting C1. That is what? You are getting the minimum out of this. You are choosing A2, you are choosing B2, you are getting C2. That is a minimum out of this. Now, when these two rules are being aggregated, you are getting an aggregated membership like this. Okay, so this range C1 and C2 range are being aggregated and you are getting this. Now, with the defuzzification of this, we are going to get the real data. How you are getting defuzzifications? You are getting a defuzzification by centroid method or something. क्या हुआ? इसका centroid तुमको निकालना है. अभी जैसे हम लोग किए थे, इसका centroid निकालना है. You have all the data with you. You have a height, everything. So you can calculate the centroid method to find it out the exact data. This is what the max product, that is Sugeno models. When you are using a Sugeno models, you see we are similarly the minimum values you are choosing, but you see the data that you are choosing, the C1 days and C2 days having some relationships. It is not like minimum value. It is somewhat max product composition is somewhat like some rule-based techniques that we are using. There is some kind of algebraic equation that you are using here. I'll show you this. If x is a, y is b, then z is f of xy, function of xy, some kind of functional relationship that you are giving. fxy is very often a polynomial function with respect to xy. If x is small, y is small, then z you are defining in terms of this x and y, which is your input, is minus x plus y plus 1. Some kind of equation that you are generating. So in that way, you are generating here. Z1 is this much. And aggregate weight finally we are getting. So examples, this is what I'm just leaving it. This is one example I'm just giving you. Fuzzy base rule, max, min, composition, no. Now, what are the different techniques? Centered method, min, max, composition. So you have a lots of defuzzification method, you see, so many. I'm not covering all, just I'll highlight this one to see. This is one max, min, composition that we have already know. Centered methods, how to calculate centered that you know. For all area, out of all areas, you can able to find out the centered of this. Weighted average is also a technique. All these are the techniques to find out the defuzzification or the centered approach. Just I'm leaving it. This is one of the case that I'm going to discuss, and finally, I can take you to the MATLAB there. Again, okay, it's available to you. I'm audible? I'm audible.
Yes, sir. Yes.
Okay. See, one of the case is there. Okay. A fuzzy cruise controller is there, where there is a speed difference and there is acceleration. Two input parameters which control your throttles that you can able to have. This is input and this is output. Now what we are doing is, in this case, two input, we are creating a number of rules. What rule is there? We are first creating a membership there for this speed difference, acceleration, and this is the output throttle control. When you are choosing the speed difference, you see we know our range setting that this is the maximum value that we can go for this speed difference. Okay, to 55 up to that. If you are choosing the acceleration, we have a range because the range is known to you. You know that in the lathe machine, what is the speed in which you can work. It can work between 100 rpm to 5000 rpm. You know that range. So that range you define first. Based on that range, what you are doing, we are making the different kind of memberships, regular or whatever the membership you want, you can define it. Now we are doing it NL, MM, NS, JD. These are the different kind of linguistic terms that you are giving, like high, low, like this. So the speed difference, negative something. These are the different terms that you are defining. And similar acceleration and similar throttle controls. All they are given. So NL, NM, NS, what is this value? NL is negative large, Z, zero, positive large, some kind of uh, linguistic terms that you are defining. Negative medium, negative small, positive small, all are given. Now you are creating a relationship between input and output. What is the relationship? If the speed difference is NL and acceleration JD, that is zero. Negatively large speed difference and zero. Throttle control is PL. PL is what? Positively large. If speed difference is JD, acceleration NL, throttle control is PL. Because you cannot have an idea of this, but you know the idea of this. तुम्हारा जितना cloudy होगा, or if you have a very cool condition and cloudy, you cannot speed, you cannot drive fast. You have to go very slow. That way, this rule are being defined, and you don't think that you cannot able to understand because this is their way in which they thought and they have calculated. Okay, so you just put out your rules. These are the different rules that has been developed. 8 rules. You can have as many as rules also. So now, based on these rules, what we are doing? First is we are giving an input here. 100 values of speed difference and acceleration is 70. If this is the data given to you, you have to find it out based on the rule, what is the value. So at hundreds, what are the membership you are getting? At hundreds, what you are getting from here? 100 is coming here. It is actually covering two different membership. One is JD and other is NS. Other are zero. So JD, NS, if you see, NS is coming membership G 0.846 and JD is coming 0.1563. For case of acceleration, it is coming 70. At 70 value, you can see acceleration is coming between the membership NS and NM. So this NS and NM having membership 0.7813 and 0.2188. Now use the rule. What are the different rules? If speed difference is what? If speed difference is NL and JD, throttle control is PL. NL and JD, NL speed difference is NL and JD. इसका JD कहाँ गया? Acceleration का JD कहाँ गया? इसका JD कहाँ गया? NL, NM, NS, JD. NL, NM, NS, JD. NL, NM, NS, JD. अच्छा यहाँ पर NE लिखा है. समझ लो ना? ये JD है. There is some mistakes here. You can see, huh? So if first rule is NL होगा, JD होगा, throttle control क्या होगा? Throttle control is PL. Okay, so now you know that ये सब वैल्यू जीरो है मेंबरशिप 100 में और ये सब वैल्यू जीरो है मेंबरशिप्स जब ये डाटा इनपुट डाटा इज 70. Now what you are doing, you are creating the rule. Based on the rule, what is the minimum value? First rule, minimum of which value? 0 and 0, NL and JD. First difference NL, you can see NL and JD. What is the value of NL? NL is 0 and JD is 0. So rule 1 is 0 here, minimum value. Similarly, rule 3, 2 may NL, rule 2 is what? Rule 2 is speed difference JD and resilience NL. Speed difference JD, JD कितना है? 0.153 and NL is 0. So minimum is 0.1563. So 0.1563 and 0. So minimum is 0. So rule 3, rule 4, all are coming 0. Rule 7, what is this? Rule 7 is coming. Speed difference JD, acceleration is NS. Speed difference JD, this one, acceleration is NS. NS is this one. So ये दोनों का minimum from the rule 7 you are getting 0.1563. So from rule 7 you are getting a value 0.1563. Rule 8 you are getting 1.0563. These are the two rules you are getting overlapping करके A1. If it is A1 and it is Y is V1, Z is C1, like that you are getting. So this overlapping you are getting between the two rules. दो rule में दो values you are getting. So when you are doing this, so what is the value you are getting? Rule 7 and rule 8. Rule 7 and rule 8 में क्या है? Output is throttle control is PS, and in the rule 8 throttle control is PM. So PS and PM को you focus it. This is PS and this is PM. These are the two output actually you are getting from this rule 7 and rule 8. Other rules are vanished. It's coming 0. So you are keeping this PS PM there, and you are choosing which value. Membership you are getting output of this two rule is 0.1563. If it can be given for first rule 7, you are 1.63, which is PS, and for rule 8 it is PM, which is also 1.63. If it will be different, you can have a different value. So your value are coming like this. You can take a line here. If it is 0.1563, rule 8 में अगर 0.2 something होता तो it will come like this. Okay, so overlapping region will be like this way. So as it is constant, so you are overlapping this whole area of PS and PM, and you have to do the defuzzification. When you are doing a defuzzification, you see the calculation how you are doing the defuzzification of this whole area, central area, and you know this range of the data. So for fuzzy set PS, you are getting a value 9.99 here. Fuzzy set PM, you are getting value 9.9 here. So weighted central will be 9.99 into 159, 9.9191 divided by 19.80. दोनों का ऐड करेगा. So finally the value we are getting 175. So your throttle values you have to maintain 175. Okay. So this is what I am ending with this. Hello. Are you getting?
Yes, sir.
So
Sir.
actually मैं खुल नहीं पाया. Otherwise installation completed. See take whether I can able open. हाँ, I'll show you something. तो अभी नहीं खुल सकता है. If you will give me time ना, sometimes I can take you this MATLAB once it will be loaded. I think it is now. I'll take you the MATLAB now. See, let's see. Some question are there. See, this is not back logic system. Answer is this. Riveting. What is the other name of the trip sets? What is the collection of the distinct objects? Logical. What is the other name of the intersection operation? What is the? So these are different questions are given, so you can have ideas. I'll take you. Leave this GUI editor. You see, I can show you here only. So what we are doing in our the MATLABs now, before I can show you here, you can see this is the FIS editors are there. Okay, fuzzy inference systems. It is there already built up tool. There is a rule editor. You can create a rule here. You can do the rules. If this is two input, you can see this is input 1, input 2. This is output 1. If you have number of input, this box will be increases. So now you can choose the relationships between the input and the output. You can create as many as rule here. And here these two input are there. You can see this is the output. So this inputs one of the memberships you can generate, and this membership and the range and these graphs all is all are custom based. You can do define by your own way. And this, once you are creating the rule, this is the rule here. You see, as I have told you in that particular slides, if you will see this particular data range, if X is A, Y is B, Z is C, something, this graph is coming, this overlapping graph. If you change this, आगे पीछे करोगे rule viewer को, if X is something, some A2, Y is some B2, Z will be C2, ये भी change हो जाएगा. And what is the relationships based on the rule and all the fuzzy input output, you are getting a surface plot here between the input, to input and output. This is the surface view. If you see a case of, this is a problem of 0 to 10, quality of the food on the restaurant, that is T problem. One rule we are given, if the service is poor and food is rancid, tip is cheap. If service is good, tip is average. If service is excellent and food is delicious, tip is generous. What you are doing here, you have a two input. One is service, another is food, and you have output, that is tip, how you are providing the tips. Now, what you have to do in the MATLAB, you can write fuzzy. If you have, you can open it. The students you can have, you can write, open it. Anybody is having MATLAB there in there on toolbox? कहाँ गया MATLAB? So they have the student having their laptop or something, the MATLABs. Hello?
Sir?
Any student having their MATLAB in their own systems there?
Sir, maybe what I did not announce before about that
Okay.
MATLAB to all the participants.
But I can show that so that they can just write it and they can do it.
Yes, sir.
जो भी MATLAB में दिखाना है ना वो PPT में भी है. Okay, I can show
Sir,
it.
sir. Okay, sir.
But ये ओपन होगा कि नहीं, क्योंकि ये है ये वर्जन 2021 का ये वर्जन है. Work or not, I don't know. Okay, within that types, let's see. See what in the MATLAB after loading you have to write fuzzy. Once it is fuzzy, now you get a fuzzy editor here. You will generate it. It is coming or not. So let's see that. आ गया क्या? Fuzzy FUJZY. Chalo, let's, when it will come, you can. So when you are writing fuzzy, this editor will come. In this editor, you have input, you have a model here, Mamadi or Sugeno. When you are choosing Sugeno, you see you have to define a relationship between this input as well as relationship in terms of mathematical form. Then only you can do. Otherwise, Mamadi में तुमको कुछ नहीं है. Only you can choose Mamadi models. Then you will have an output here. What you are getting here, and minimum, maximum composition, application, aggregate, and differentiation. Your differentiation you are getting centroids. This is what maximum composition. See input here given. This is 0 to 1. That means this input you can check the range between 0 to 1. You can change it also. You can click, double click here. You can do the changes there. Let's see. See what we are doing. Service, and this is the food. What?
Sir, actually, not visible the slide, sir.
Not visible.
No, sir.
लेकिन अच्छा फिर शेयर नहीं हो पाया. Let's check. लेकिन I'm sharing it. मेरा फौजी खोला कि नहीं, ये भी नहीं खोल रहा है. It's coming or not. Let me share first, then only enter screen.
Okay, sir.
Enter screen, enter screen. और शेयरिंग इसमें वो सिस्टम नहीं है 2021 में मेरा, इसलिए ना.
Yes, sir.
ना. Okay. So okay. So see, this you have already seen.
Yes, sir.
See, you have to write a fuzzy here. Okay, when you are writing fuzzy, this particular toolbox will come. You have a relationship. You come with input, any models, that is inference model, and the output. In this inference model, you have two options, Mamadin and Sugeno. Choose better way is Mamadin because you don't have to do anything. But if you choose Sugeno, you have to do something there, like mathematical or algebraic equation you have to develop there, as I told you in the PPT. After that, what you have to do, as like service and food, we have a rule there already. This is two input and output is your tips. Okay, now what we are doing, we are clicking here, service. You see, service, we are choosing the range here, 0 to 10. When we are choosing, you can see the range is coming 0 to 10. You have option there. You double click, it will ask you the type of membership you are defining. So this is the Gaussian membership you are defining. You have other regular membership. You can choose your other membership. You can define your range also there. You can define the range of each membership, that this particular membership will vary from this to this. So in that way, you can choose this type of graph there within this range 0 to 10. Next is, you see, when I'm clicking here, service, if you see, this is the membership that is coming. This is the membership that is coming. This is one membership, poor, this is good, this is excellent. Three kind of members, three kind of this data. So three kind of membership we are defining, and the values poor is here 1 for Kesa, service is 0, and this poor values goes reduces to this, and this is a Gaussian kinds. That's why, see, this is Gaussian. And you see, one link has been given. This excellent one has been clicked. So that's which value is 1.5 and 10. That means we are giving a parameter there at value 10. Okay, and this parameter 1 and another is 0.5. Okay, so in that way you are defining this particular. Similarly, you have to click here, you have to define your parameter so that this good membership will come. So this way you can define your memberships. Next is, this is what the service. You see here I am just clicking poor. Okay, you be poor could Gaussian membership is there. You can choose a triangular membership. Now you can choose your parameter there, 1.5 and 0. See, 1, 5 and 0, 1, 5 and 0. 1, 5, you see 0 and 5 are there. It varies from 0 to 5 and your membership is 1 here at the particular value of 0. So in that way, Gaussian membership are being defined. Okay. So in the same way, triangular also you can define. यहाँ से लोगे तो यहाँ पे उसका रेंज देना है, रेंज देने के बाद मेंबरशिप को देना है, तब जाके वो डिफाइन हो जाएगा and it will give you the values. See, range is given displaying here. You see, this range is displaying. So you can play with this. Select and edit and attribute of the membership function. You can do it. This display, edit and values, edit the currents. So now this is what name and edit the parameter of the membership. You can edit it. Now you are defining the member, the tips member tips. That service poor, food and seat, so tip will be very cheap. If service good and only if the service is good, then tip is average. That means you are not having any criteria of food here. If the service is excellent or food is delicious, that tip is generous. In that way, you are defining this rule. You see, these are the memberships are given, and you are choosing these and tips. Rule 1, rule 2, rule 3, like that way you are ready. Choose this, add it. There is a rule, add rule. Choose this, add rule, all this way. So after doing this rule, so you will get it. Rule automatically updated. You are adding it, then it will be rule added. Then finally you will get a rule here. And now here at particular value of 3 and 8 input, at particular input conditions, you have output here. You can see you have output here at particular value of 388. You can choose this way input, changes your input, your service, your tip will be varying there. It automatically give you a different results. So the how the input variable used is the rules. And finally, you see, if we give you a service of 4, food is 10, you have to give a tip of 19.7. Like that we can change it. And the surface plots of this whole based on the rule here, you have a relationship between the input and output, you can get this surface. A system output versus this. Now I think I have completed my times. And who got it? Anybody has any question, then you can ask. It's okay with you?
Yes, sir.
Or can you give some times, let me load it MATLAB if they want actually. This is what I have to do as what I have given in the presentation. No? Same
Sir.
thing I can define. Same things I will do it, nothing more than that. Like this particular case also, let me tell you some more. Do you have any presentation after this 11:30?
Yeah, sir, 11:30 to sir 1.
So then I have to close my this presentation then. Okay.
Sir,
Because so I'll stop it. So thank you for attending this. And if you have anything, sir, I can discuss with you.
Sir, participant, sir, one participant, they have asked some question in chat box.
Actually, let me check the chat box then. Where is chat box? Where is this is the chat box. Yes, Alok Kumar Jha. Sir, we can create the model in MATLAB, but how the same can be implemented in real times? Yeah, that's a controller you have to use. Okay, you have to fuzzy controllers, that is electronic circuits. That's logic gate are there, so you can create that rules there. Okay, within this. How this real times you can do? You can do it through the controllers. You have to use the electronic circuits there to develop. Anybody else? You see what is the things. When a controller, you are preparing a controllers, you have an input gate there. Okay, now you have this range, no? All this. Now the case is rule, and you are creating the rule through what software based. Logic gates, the software will calculate all the data. It will give the feedback to the controllers. Controller will give you this data, and input output signal will be delivered. So this is the way simple approach. In like Crisp data, that exact information you are giving, you are giving a logical approach by which you are creating. That's why the washing machine has been generated. No? You can do all this. Okay, so anybody else?
Any question from participants? You may put in chat box or unmute or direct to sir.
So you can anything you have also you can send to mail. Okay, I'll respond to you in my mail ID if you have any data ideas. Okay. So.
Okay, sir.
Okay, thank
sir,
you.
Thank you. Okay, sir. Thank you for the sharing your expertise in the field of fuzzylogy and fuzzy application, and especially we have get knowledge in the field of introduction of fuzzylogy, then soft computing, and then fuzzylogy toolbox, then classification, then whatever the Crisp set, then fuzzylogy system, then real world problem. Then we have got a lot of things. Already have also knowing last how to you have to use the toolbox. I think which is very interesting, and I hope all the participants acquire this knowledge about the different technique and new innovation in the field of anywhere. So thank you, sir.
Okay, so thank you. So I can leave now.
Yes, sir. Thank you, sir.
I think I'm not audible.
Yes, sir.
Sir,
namaskar.
Sir, it is audible.
No.